everyone. Today we will see how we can containerize our .NET application in Azure. Here we can see the history of .NET releases from 2002 to 2017. Different versions with different SLI comes into a market. We can also see that many of these versions has lost their support from Microsoft. We can see that these are the development tools which we can use along with our .NET versions. These are our Windows or Windows Server versions which can be used with different versions of .NET. We can also see that which version replaces which version. Now, the thing is why Docker is required. Because Microsoft .NET Framework has successful application platform for last 15 years as we have seen in our last slide, which have countless business critical apps are running on older versions of framework and older versions of Windows servers, which make it difficult to maintain, upgrade, extend, and manage. Also, it needs a huge investment for rewrite. Now, where the Docker fits in .NET solutions? We know that Docker is a lightweight container. Uh, for example, Windows Server 2016 and Linux. It adds new features like monitoring, increases security and performance. It supports continuous deployment that reduces need of lengthy and expensive rebuilds. It supports server-based applications like WCF, .NET Console, apps, and all the flavors of ASP.NET, APIs, messaging solutions, and other components that run in the background like databases. Now, where this Docker's continuous deployment fails, in case of a desktop apps like WinApps and WPF apps, because there is no UI integration between Docker platform and Windows host. But still, Docker provides a provision of using image to Docker, that is lift and shift for desktop applications. Now the question which pops up in a mind is that in case we have to go with the Azure, then I can also go with PaaS as it also supports continuous integration and delivery. It also provides security monitoring and performance. I can also go with IaaS wherein I have a right to configure my own infrastructure with better security and less cost. Then why we should go for Docker? The simple answer to the question is that there is no code change. Moreover, it provides extra features like security, performance, scaling, and monitoring. And the simplicity of Docker is that we only need a small script like Dockerfile, which helps us to automate all the steps of deploying the app. If we see the process of moving to Docker container is a three simple step, that is building an image, pushing image to the registry, pull image from registry to cluster. This is our, if we see to this picture, we can see that on the left side we have our own development environment wherein uh, the Docker build the image using a Docker for Windows or Linux image repository, then it push it to the Docker registry, which can be Azure Container Registry or a Docker Hub, and then it pulls that registry, that image from registry to Kubernetes cluster, that is on Azure. Now, if we go to this slide, we can see that Docker supports different versions of .NET. If we start with .NET Core 2 and .NET Core 1, we can see that we have a support for continuous integration and delivery using VSTS and Jenkins. Along with that, we also have a support for Linux. We can have we can use Docker to Linux and Windows. We can use Kubernetes on Windows and Linux. And if we check for the version 4.7.1 to 4.0, we can see that we do have a continuous integration and continuous delivery support using VSTS and Jenkins, but here we do not have a support for Linux. And in case of version 3.5 to 1.0, here we do not have a support for continuous integration and continuous delivery, but Docker provides a provision of lift and shift using image to Docker tool. talk about framework 1.0 to 3.5, using image to Docker, it's very easy to deploy to ACS. By using the simple command of install module name image to Docker in a PowerShell script, it gives access to a Windows artifacts and convert to Dockerfile command. By using a convert to Dockerfile command, we can convert the whole VHD into an image. In case we want to extract a single website from IIS virtual machine, then we can use artifact IIS using artifact prem and giving a name to an image ASP.NET Web API and moving it to the output path like CI2 or any location you want. Then we move on to that location by change directory command, and then we will build an image using docker build command, and then run image using docker run command opening port 8080, and this simply deploy an application to a container. But in the case of image to Docker, we cannot do a continuous integration and deployment in case the application is under development stage or it's in a continuous change state. In case of .NET Framework 4.0 to 4.7.1, there is a support for continuous integration and continuous delivery, and the requisite for doing that deployment is that we need a Visual Studio 2017, Docker for Windows, Kubernetes cluster, container registry, Docker file, deployment file, and SQL deployment. So if we talk about Kubernetes cluster, we can create Kubernetes cluster on Windows using this command, wherein we are directing Azure to create a Azure Container Services using a create command by orchestration type as Kubernetes and resource group whatever we want, and the name of a cluster, giving a count of 2 as an agent, generating SSH keys, and for Windows agent node, passing on the username and password. This is for a Windows. And to create a Kubernetes on Linux, we can pass this command wherein we are not giving a password for Windows because the agent node is also Linux. In case we want to connect the Kubernetes from a Kubernetes cluster on Azure from our client, we have to install a command line interface. By giving this command, we can install a command line interface. We can connect to a Kubernetes cluster using this command from client side. Then by passing kubectl proxy command, we can browse the UI of Kubernetes. And we can also create a registry going to the Azure portal and simply by creating a registry. We can also check here that uh, this is the cluster, this is the Kubernetes cluster which we have created. Here we can see that 2 nodes are created. These are the agent nodes, Windows agent node, and their operating system is Windows. But by default, their master node is Linux. Here we can see that the operating system is Windows. This is our Kubernetes cluster, and if we go to its uh, and this is the URL which we can use to connect to the Kubernetes cluster. And for a registry, we can create a new registry by going into the more services. We can add a new registry and create a registry. This is the registry which we have created for our demo, right? This is the registry, and these are the images which we will deploy. Now we go back to our this demo. Here we also talk about Docker for Windows. Uh, this is a software which we will install and can see when it is installed. We can see here it is running, right? Now this is the application. This is a legacy application we are using, which is developed in 4.0, right? By right clicking over it, we have a option of Docker support. By clicking that uh, option, we get a Docker file added into this application. We can see here the command of Docker file. Basically, it is publishing all the build material to a particular location. Now we can see that we already added our project into a VSTS. If we go to VSTS, this is my VSTS dashboard. Here I already created one project, that is eShop, right? And by creating a after creating a project, new project, I go back to my this Visual Studio and manage connection. Here in eShop, I created one workspace over my laptop and pass all the items and items to my VSTS, right? And when I open it, I can find that we can check it and check out this application. Now we go back to VSTS. Here we have to create a new build definition, right? We create a new build definition. We select ASP.NET with container support. We added the agent queue as hosted VS 2017. Right after adding that ASP.NET with container support, we get NuGet um, task by default. We get NuGet restore. We get build solution. Right, we need not to change anything in here. But when we comes to build services, we can see that here we are building a services using Docker Compose file, but we are not using this task, so we delete it. And we add new task. Here we can see that we have a two tasks, that is one is Docker and another one is Docker Compose. We will add Docker task wherein we can build images using a Docker file, right? Now we will build an image. We will use our Azure subscription. We will add our container registry which we have just created in our Azure. Here we are using a Docker file. We keep other things same, use the default build context, qualify image name, and also we check in the include latest tag option. Then we go to the next task. Herein we will select an action as push an image. Here also we'll add our subscription. We will add our registry and check the include latest tag. Here we can write any name here, copy template files or whatever. We can add the source folder. This is our agent build directory, wherein we are copying all the files from this particular build directory with a content with YAML file or YML file. And we keep the target folder as artifact staging directory. This same target folder we will use in our publish artifacts here with the path to publish. And to avoid the confusion, we change the name of artifact name and then we will save and queue it. We created a new definition. Now we can go and check the build of our definition. Once this build is created, we can create a release wherein we will pull all the image which is created in our this registry. If we go to Azure registry, after this build we can see that this image will be created with the tags in it, with the latest tag and all other tags. Now we will go to our code. Here in code we had check in new file, that is deployment.yml file. Here we are writing the code to deploy it in on our Kubernetes cluster, right? So this is the code script which we have written. Here we are creating a port, right, and picking up the image from our registry. We go back to our build. We can see that it's in a progress. Now by the time it is building, we can go to our release. We can go to a definition which we have already created. Here we can see that we are creating an environment and the artifact is our build artifact. Whatever we build, uh, the same will be used as an artifact here. And apart from that, we use this trigger for a continuous deployment. That means once the build is created, then this release started automatically. Herein we have taken one task. The agent which we have used is same, that is hosted vs 2017. We created one task wherein we create a Kubernetes service connection. In this connection, we can see that we have created a Kubernetes connection. We have used that cluster URL which I have showed you, and in this kube config file we can go by writing this command we get a config file created in a kube.config location. Under this we can see the config file is created. It is basically a path to that cluster, Kubernetes cluster, the same URL, and we copy whole of this um, content and paste it into our in our kube config text box. Then we go back to our release. Here we select this connection. We select the command of apply. We click the checkbox of use config files. Here we added the deployment.yml file which we have just created, and then we in a registry details we add our subscription. We added our registry. We create one secret name. This can be any secret name in a small letter. We force update secret means each time when release is generated, this secret name is updated, right? Then we click the checkbox for a latest version. In an output, we change the output format to YML, right? Now, when the build is done, then release starts, but it haven't done yet. So once that whole process is completed, we can uh, write this command kubectl proxy, which will start our UI, and we can see that our application is deployed here, and it created one service with an external endpoint as this, and uh, created a code and a deployment. We can click over this link and check that our application is working or not. For deployment of a SQL, we can go to this location. This is our SQL deployment YML. Here also we are deploying SQL data and creating an image using the username password, managing the load balancer and opening these two ports. And by writing by writing uh, this command over my script over my command line, I can uh, deploy my SQL to uh, um, container. So now we can see that our application is running. Here it is running. I can edit it. I can save and see that the change is reflecting. So this is how we can deploy our this application to container using continuous integration and deployment. Only by doing a build and release we can do this. Now, if we go with the .NET Core 1.1 to 2.0, in that case, as we know that .NET Core supports Linux, so here we do not need Docker for Windows. We can use Docker for Linux. In case of Kubernetes cluster, we can go and create this cluster with uh, 3 Linux agent nodes. And for container registry, we can use same container registry. For Docker file, uh, here the change is that from ASP core 2.0 as a base, we will run our thing. Here we are using, in case of Windows, we are using Microsoft ASP.NET 4.7. Here we are in case of .NET Core, we are using ASP.NET Core.20. Here also we are publishing our build to a particular location, and using it in our uh, VSTS. So if we go for this .NET Core, this is my .NET Core project, that is Final Core. I go to its build um, definition. The difference is I'm not building here. I'm directly build an image, push an image, and copy and create the template. Everything is same. The difference is that I'm using this time hosted Linux preview as an agent queue. And also the difference is that I this time switch to Linux Docker. Here comes an option of switching between Windows and Linux. So this time I'm using Linux, switch to Linux Docker. And uh, in a build image, the things are same. I'm doing the same thing. In a push also, I'm doing the same thing. There is no difference in the definition. And in case of a release, uh, I'm using uh, a different cluster URL. That is my Linux Kubernetes cluster. And the config file is also different. This is my config file for Linux. Here it is my cluster. Basically, after switching to Linux, I run I run this particular command on my command window, and it creates this config file for me, which I copy pasted on my kube config text box. Rest everything is same, no difference. And when I run it on my kube, Kubernetes UI, I can see my final core application. So this is all. Thank you.